Well, good afternoon, everybody. My name is Larry Gastiger. I'm the Executive Director of WIRES, and I'm pleased to introduce the second installment we have in the WIRES webinar series on innovative technologies. And we're pleased to have a presentation today on advanced reconductoring. And for that, we have two folks from a longstanding WIRES member, CTC Global, to provide the presentation. But before we get into the actual presentation itself, I want to let our attendees know that our presenters have agreed to take any questions regarding the presentation. So as we're going through the presentation, if you think of any questions, you can include them on the question function, which is on the right-hand side of your screen. If you tap on the question function, you should have a drop-down, and you can put your question in there, and we will make sure that we get it to our presenters at the end of the presentation. And for now, I'd like to turn to introduce, first of all, the two folks we have from CTC Global. First is Peter Brem. Peter is the Vice President and Senior Advisor for CTC Global. And then we also have Dave Bryant, who's the Director of Technology for CTC Global. So Peter and Dave, thank you for being here today. I'm going to go ahead and turn it over to you and let you go forward with the presentation, and then we'll deal with any questions we get once we get through the end of your slide deck.
Thank you very much, Larry. Welcome, everybody. Thank you very much for joining us today. I'd like to introduce one colleague who's not here, Dave Townley. You see on the slides, many of you may know Dave. He is in semi-retirement now and had family obligations today, but he's still very involved with us and had a lot to do with putting the presentation together. And I'd like to now introduce my colleague, Dave Bryant, the Director of Technology for CTC. He will be presenting the first part of the presentation today, focusing on the technologies themselves, and then I'll join you back toward the tail end of the presentation, talking more about challenges and policy initiatives. So Dave, I'll turn it over to you.
Thanks. Good morning, everybody, and thanks for your time. Yeah, a quick shout out to not only Larry and Drew, who have helped put this this new Tech Talk series together, but I also wanted to express my appreciation for all the work that people have been doing behind the scenes to support the WIRES members and associate members like CTC Global, including London Economics, Brattle, and more recently the Charles River Associates. The reports that have been generated over the last 10+ years since I've been a member are really astonishingly good work, and I really appreciate it. Drew, why don't you go ahead and jump into our agenda. So we really want to talk about, at WIRES request, they wanted to really hear about the challenges, the opportunities, and applications for advanced conductors. So we're going to talk a little bit about the background in terms of what's been going on. We want to help explain some of these technologies and how things have evolved. And then we're going to cover some policy issues. And I apologize, not being able to control the slides, I'm going to have to just dump a bunch of text at you quickly. But hopefully you can run through here and get a better sense of what we're going to cover. We want to talk about grid enhancing technologies and the evolution of them into advanced transmission technologies, and now, as we call it, advanced reconductoring with other grid enhancing technologies. There are a lot of things that have changed in terms of the benefits of and performance of high performance conductors compared to earlier generation high temperature low sag conductors. We want to talk about the advantages of reconductoring, and we want to consider some of the challenges and opportunities for continued and accelerated deployment of these technologies. Now we are going to talk about different types of advanced conductors that use different types of technologies in core, but again, reflecting on what is this advanced conductor stuff compared to just a high temperature low sag conductor. And we look forward to any questions that you guys have at the end of this thing. So thank you. So initially, from my point of view, grid enhancing technologies were really looking to find non-wire solutions that could help improve the efficiency, capacity, reliability, and resilience of the grid. A lot of these devices were designed to detect what was going on a transmission line, evaluate temperature, sag, other things like that that could help grid operators take that information, apply it to their systems, and hopefully be able to squeak more out of the system. Now, I remember when we first started 20 or so years ago, I worked with Tap Sepp at the Valley Group, and some of his dynamic line rating systems, and I've probably seen 15 different versions of this as it's evolved over time. But I think the most important and most exciting aspect about this is that utilities and grid operators are now much better positioned to take advantage of all this data. So that's a fantastic thing, and these are really exciting times. Drew, go ahead and punch me forward. So as I mentioned, these are really changing times. There are different types of grid enhancing technologies. Some are software driven to provide information and get that quickly, with sensors and things like that in the field. Other things are more hardware based, that we can use actuators and control the power flow. That's proving to be highly useful. I know that some of the newer companies that have been very successful in deploying these technologies, not only in North America, but some really great projects in Europe. And I look forward to hearing more tech talks from groups like WIRES members like Line Vision and others. So there's going to be a lot of exciting updates to come. One thing that I'd like to point out is that grid enhancing technologies, from one perspective, are very much a non-wire solution. But the fact that we go ahead and pop forward, Drew, if you don't mind, it's really exciting to see the government start to understand that advanced transmission technologies also expand the limitation of just like dynamic line rating systems and stuff like that. And again, as I mentioned, it's pretty exciting to see that more and more grid operators are able to actually use dynamic line rating systems, load flow controllers, and other technologies. So that's fantastic. Ambient adjusted ratings was the key word that I was looking for in my notes. Sorry about that. Okay, so as I mentioned, DOE added advanced conductors to advanced transmission technology category that includes all types of GETs. And just a couple of days ago, National Caucus of Environmental Legislatures asked FERC to finalize transmission ruling, and they wanted to make sure that they considered 4 major features. They want us to consider all of the holistic benefits of transmission investment. And I know a lot of the WIRES documents over the last decade have gone deep in that. If you invest $1 million in transmission, what can you expect to get out of it? And it's usually about a 4 or 5 times improvement over what you invest. So it's great investment, and we all pretty much know that stuff is good, and a lot more work is needed. One thing that's still kind of up in the air is how do we allocate costs between the states? If you have a transmission line that's running from Wyoming to California and it's just traversing other states, how do we balance it so that people are not overly paying too much for maybe something that they're not, a service that they're not getting? So there are a tremendous number of efforts underway with the different trade groups and industry leaders that are really driving this stuff forward. And again, these are really exciting times. Another thing that the National Caucus really wanted to recommend is that considerations be given deeply to the changing mix of generation assets and the changing load considerations. There is a very dynamic time, and it's easy to shoot a pigeon when he's standing still, but when you've got a flock of them and they're running through it at 60 miles an hour, it's a lot more challenging. And that's sort of what we're at right now. We're at Mach 60 in terms of seeing all of this stuff evolve. It's really exciting. One nice thing about the verbiage in this most recent letter, and this is just representative of one of many, is the fact that they're suggesting that they incorporate advanced transmission technologies, including high performance conductors and other devices, conventional GETs, into the consideration, into the mix, so that these technologies are leveraged and they're considered during the planning phase. They're considered early on, not after the fact. Oh gosh, if we would have done this, something good might have happened. They want us to think about it ahead of time.
Let me add a little to that, Dave. That's a good point. There's several different descriptions of GETs traditionally being more software and not a wire solution. We like to always say, at least CTC does, like to call it advanced reconductoring and other GETs. It's not that all advanced conductors are GETs technology. When advanced conductors are used for reconductoring, we view that as a GETS technology because something can be done relatively quickly, 6 months to a couple of years. Also, as you see the point from the legislators below, there's a term that's now being used called high performance conductors. That term is generally being used now to describe advanced conductors and superconductors. And I might point out that the advanced reconductoring term actually came from our Secretary of Energy, Granholm. She kind of came up with that. She's a good marketing person for us. Thank you. Thanks. Next slide, please.
Well, if for those of you that have known me for the last decade or two, you've probably heard me talk about advanced conductors, but I'm going to give you kind of a highlight here. We found that carbon fiber is an excellent material for the use in advanced conductors due to its high strength, lightweight, and dimensional stability. In other words, when conventional wire heats up, when you run a lot of current through it, the electrical resistance causes it to heat up, which causes the materials to stretch, resulting in conductor sag. So being able to use a lighter weight core that's stronger, that also has resistance, great resistance from vibration-induced cyclic load heat, makes it really an ideally suited technology to this application. And if you read the magazines, you'll see that a lot of other entities have also discovered that not only are these conductors being deployed much more broadly than they had been in the past, you're also seeing other people that are proposing new and unique designs. One of the biggest benefits, besides being able to carry more current, is that their lighter weight core can also include more conductive aluminum. And the added aluminum content not only supports high current capabilities, it also does it more efficiently. And reducing line losses is a big thing. I don't remember exactly where a report came from. There's East Coast University, and they about 2 years ago, they discovered that nearly 1 billion metric tons of CO2 are blamed or attributed to poor conductivity on power lines, poor efficient power lines. So being able to improve the efficiency of a power line has huge impact with very substantial results. I'm going to show you a case study here in a couple minutes. It'll talk about that a little bit further, but it's really exciting to see these technologies evolve and thrive so quickly. Keep in mind that legacy ACSR conductor has been around for over 100 years. One of the early producers of a high capacity conductor, high capacity low sag, was 3M. They use a metal matrix core that's depicted in the list of pictures below. Tokyo Rope also introduced their product around 2001, 2002. They did some nice demonstration projects for the first decade, and now they're coming on a little stronger. I think they're now working with Southwire to also have another product offering in their line. And then more recently, or actually 10 or 15 years ago, we saw Nexans, who's a pretty well-known producer of high quality cables. They came up with I think they call it low sag conductor. It uses an all carbon rod encapsulated by aluminum. The CTC product, ACCC conductor, that's now manufactured by about 35 different companies around the world. We chose a hybrid carbon and fiberglass wrap to improve flexibility and toughness, and also provide a resistance for galvanic corrosion. Go ahead, Drew. Okay, so again, when we introduced ACCC conductor back in around 2003, commercialized a couple of years after that, one of the key things that we recognize is that sag is a drag. There is a major East Coast blackout in 2003 that was attributed to uncalibrated telemetry devices, poor communications, and other things. At the end of the day, it was sagging conductors that caused these cascading blackouts. So our number one goal was to reduce the sag so that we can avoid those types of problems. The added aluminum content, as I mentioned, helps reduce line losses, and that can improve economic viability of not only renewable generation assets, it can also reduce fuel consumption and emissions from fossil-fired generation assets. So being able to reduce emissions is a big step forward. Now, the slide that you see down below was taken from testing done at Kinetric's lab by Hydro One. This goes back at least 15 years ago, and they ran different conductor types on a 225-foot span They ran these in series with the ACSR conductor. That's depicted in the red line that drops into the low zone. And they looked at other high capacity or HTLS conductors, and they found that even though those conductors were able to operate at higher temperatures, unfortunately, their sag characteristics caused them to kind of sag out before they could reach their maximum capacity. So they might have had a 50% increase, but other technologies that have improved sag characteristics can double or even more provide that higher increase. The other thing that you can see with that blue arrow at the top is that in this case, the advanced conductor, the ACCC conductor, operated at 60 to 80 degrees C cooler than the conventional types of technologies. And that cooler operating temperature really underscores reduced line losses. Everybody's familiar with I²R line losses. If you have improved efficiency, you can reduce those line losses substantially at those higher temperatures. Although these conductors aren't designed to operate at those temperatures all the time, they've got the ability to when you're cranking it up. So great solution for this application. Drew? Thanks. So as I mentioned, being able to use advanced conductors or reconductoring with advanced conductors to double the capacity of the existing transmission line is really the sweet spot for this technology. We can do this, we can double the capacity without having to replace or modify existing structures. That is really the sweet spot. Out of the 1,100 projects that we've completed thus far, about 10% of them have been new lines because there are certain advantages to high strength and low sag and efficiency. And they're being specified now by some of the international development banks because they like the efficiency aspect. But being able to upgrade the existing transmission system, sometimes with or without substation upgrades, is a super cost-effective and very fast way to get what the line needs. It also, as the note mentions, it can be done very quickly. So you're reducing project cost and you're reducing project time frames. And you're also freeing up people and equipment that can be used to work on other projects. So those are a couple important points about reconductoring. A couple other things. Most projects that I've seen approved in the United States have been categorized as reliability projects. In some cases, they're working on mitigating a sag infraction, or they want to have added capacity for N-1, or they just want to increase the capacity overall. Many of the projects that have gone through the permitting process very quickly are really designed to help improve grid reliability. Other things that, in fact, I just saw just 10 minutes before we started, I saw ITC posted a LinkedIn note. They mentioned that 184 million megawatts of energy never reached their customer due to grid congestion. So by being able to mitigate grid bottlenecks, we're going to be able to not only deliver more clean energy, we're also going to be able to help reduce costs to consumers. So the price tag for some of these big interstate projects is really big, but the benefits are much, much bigger. And it's important for the planners to to consider all these things as they're penciling out what they think they need to do in the next 5 to 10 years. Now, the sustainability goal aspect is something we've been promoting for me for a couple decades, and we're talking about efficiency matters. Not everybody is out in tune with the efficiency thing, and I know that a lot of transmission entities in the United States have developed, or utilities have developed, sustainability goals. We believe that considering the efficiency of advanced conductors can help utilities achieve their sustainability goals. And we've seen a number of projects in places like Malaysia and Africa and Bangladesh and India, where they're actually receiving funds from international development banks that support not only the delivery of lower cost electricity, they also appreciate the reduced line losses can relate to reduced CO2 emissions and/or the ability to deliver more power from existing clean generation assets. So it's a big win for everybody. And again, here in the West Coast, we're dealing with a lot of fires, and being able to mitigate conductor sag to keep the wire further away from vegetation is a big win. The other thing that's nice about advanced transmission technologies and these high performance conductors is that they can handle a lot of temperature without being damaged. So we've seen conductors that have been exposed to fires and they've survived really, really well.
Yeah, to add a little bit to that, we sometimes like to say we have, I don't know if any of you are history buffs, but in the Second World War, our fighter planes had something called WEP, War Emergency Power. Well, one of the nice things about our conductor is that for meaningful periods of time, it can be run beyond spec without the long-term damage or excessive sag. So that's an attribute that we're seeing more and more people being interested, particularly outside of the U.S. because they have much more peaky flows at different times. But just it's one we probably don't talk about it as much as we should. But the ability to rather than having to curtail, say, some wind power, if you give up a little bit of efficiency, you can run it hot and over capacity for a meaningful period of time without doing any damage to the line. Go ahead,
Thanks. Drew. This is like a rock star project that was completed by American Electric Power in 2016. They actually won the Edison Award in that year. One of the things that was most remarkable about this project, it was the largest energized reconductor project ever undertaken. We had done a number of these in South Africa and other places, but the AEP project, they reconductored 240 circuit miles of 2 parallel 345 kV lines. They used Drake size ACCC conductor to replace Drake size ACSR conductor. They chose the technology because they had about a dozen projects worth of experience. They had a high level of confidence in the product, and they were able to do a reconductor as opposed to a rebuild in a fraction of the time at a fraction of the cost. And even though they achieved their goals of being able to improve essentially double the capacity of this line to accommodate peak conditions in the winter and the summer, generally this line idled along. I think it was a load factor of 34% load factor. So it's pretty low stress line.
Dave, you're off one slide. This is the efficiency slide.
Okay, well, if you look down at the line losses of that product.
Yeah,
oh, I'm sorry. Okay, so I'm sorry. Thank you. So
yeah, no worries.
This slide talks about how much energy we've saved over time. And currently and thanks, Peter. I'm sorry, I just kept babbling on.
No worries. No worries. I didn't stop you early enough.
That's okay. So currently the ACCC conductor saves about 10 million megawatt hours every year. That's enough to power almost 1 million homes or recharge about 2.5 million cars. And the CO2 emission reduction continues to grow over time. So it's a very, you squeeze a lot of juice out of a rock that you didn't know had juice in it. And so it's great. Yeah, well, I'll make a quick point here. Thermal power plants typically use about 12,000 gallons per megawatt in many of the systems that still exist. So if you're interested in saving water, this gives you another option for that. Excuse my stupidity on hitting the wrong slide, but go ahead.
Now you can talk about the award-winning project.
Okay, I think that one's next. There you go. Thanks. I'm a forward thinker. You know, what can I say? Okay, so AEP did a great job with their project. I mentioned 240 circuit miles, 345 kV line. And not only were they able to meet their objectives, they also were able to reduce line losses by about 300,000 megawatt hours every year, which saves consumers about $15 million. Now, I don't remember being able to buy electricity for $50 a megawatt, but assuming that was the bottom line, $15 million savings every year, essentially quickly, in months, offset the added cost of an ACCC conductor compared to like an ACSS conductor that can handle higher temperatures and increased flow, but not as efficiently, and they would have had to replace structures because of the sag and the spans. The other thing that's also interesting is that based on all sources of generation in Texas back in 2016, which wasn't that long ago, they reduced CO2 emissions by about 200,000 metric tons per year, which is the equivalent of removing 42,000 cars from the road. And this project was not that expensive, even though they did major substation upgrades to accommodate the extra stuff, and the project was completed very quickly. Can you imagine the cost of buying 42,000 Teslas by comparison to get the same reduction? And understanding that many of those Teslas are still going to be powered by fossil-fired resources. So the bang for the buck as it relates to helping utilities meet sustainability goals and reducing emissions is pretty remarkable. And if you get a chance to look at the slide deck again, you can go back to the last slide and take a closer look at some of those bigger numbers. Thank you.
Dave, I'd ask you to go ahead and make your point again, because this was an award-winning EEI transmission project of the year, and a big part of that was you might want to revisit the live reconductoring.
Okay, so in order for AEP to do this project, they hired, well, it was a division of Quanta Energized Services. They added a D phase, so they put up some temporary wood poles, and they were able to use that to run current while they took down one wire at a time. So they were able to do it while the line remained energized. Very, very effective way of doing it, very safe way of doing it, and a lot of experience has been gained. So highly successful project. And even though it was they did it in the fraction time of a conventional rebuild, they still came in 8 months ahead of schedule on their project using energized reconductor technology. And they have agreed to help other utilities in different countries learn how to do this stuff so that it can help them as well. Stellar group, stellar effort.
Go ahead, Drew. Thank you.
Thanks to some of our, CTC was a joint funder of the Grid Strategies report that was written by Jay Casperry and Jesse Snyder, and this came out just a little over a year ago. And what they tried to do is they tried to look at it. Well, they're mentioning that there's a lot of transmission lines, so 200,000 miles or so, that are coming up on 60 years of age, 50 or 60 years of age, and that they said, let's look at a bite-sized piece. If we upgraded 2.5% of these lines every year, that we could add about 27 gigawatts of renewable every year. We do it for 10 years. That's a lot of extra renewable energy on the grid. They also found that they could enable 3.5 billion megawatt hours of renewable to be distributed efficiently, which is great. They also calculated that they could reduce CO2 emissions by 2.4 billion metric tons, which is like the same thing as shutting down 800 megawatt coal plants, and that was at a 85% capacity factor. Now, I don't know exactly, I didn't read all the calculations behind the report. I read the report a year ago, and it was really impressive. But I do know that while these numbers seem really big, I can think back to some people that explained in detail in some of the WIRES reports that it's a lot less expensive to save energy than it is to produce it. And so again, we've had completed 1,100 projects in 65 countries, and with a couple of demonstration scale exceptions, every utility, and there are over 250 of them, chose this technology because it provided them with the least cost solution. It may have cost a couple extra dollars up front, but the payback times were measured in months. So it's really good technology to look at when you've got a challenge that you're facing. Last slide for Dave is up next, Drew. And I think I've already burned enough daylight talking about this stuff, but again, higher capacity reduced sag can improve grid reliability, help integrate renewals, mitigate bottlenecks, and reduce consumer costs. And if you're going after ISO that needs to approve your project, if you can highlight the fact that demonstrate that you're reducing consumer costs, that there's a chance that you might get moved to the front of the line. So these are all good things to consider. And as I mentioned, it's a very fast and efficient way to increase capacity and resolve these other challenges that many utilities face. And as we think about sustainability goals, and you need to put this right at the top of your list of things to consider. Thanks, Drew. Oh, and it saves money.
Ready to start my part, Drew. Thank you. So Dave's hopefully did a very good job of presenting the technology, all the guest technologies, but also obviously advanced conductors and advanced reconductoring. So the question is, if you listen to Dave's presentation closely, hopefully you will agree that advanced conductors, advanced reconductoring are the next best thing to slice bread for the transmission industry. ACSR have been a really innovative product, you know, shortly after, or shortly before, and shortly after the First World War. So why, if that's the case, why has the rollout been relatively modest? Speaking specifically for CTC, the U.S. is not even in our top 10 markets. We are dominant in any of the markets around the world where you have rapidly growing transmission. We're big in Indonesia, Bangladesh, Malaysia. We just announced a new facility in a new manufacturing facility in India. We have a facility in Paraguay that serves South America. But again, the challenge in the United States is our market's somewhat unique. As you know, we have many utilities, we have many regulators, and everybody's been taught to work a certain way for a long time, and it's challenging to get people to change. So this comes from the DOE Advanced Transmission Technologies report. It's more than just advanced conductors, but obviously it's an issue with advanced conductors as well. Next slide, please. So again, following up on the challenges, again, very similar. The Department of Energy recognized that there are these challenges. There's actually some efforts underway at the Department of Energy to identify barriers to adoption and to help remove those barriers. We understand OE, Office of Electricity, has been charged with this by the Secretary of Energy, and they are actually working. We've been getting some questions from some of the labs recently. Several of the labs are heavily engaged in this effort to, for lack of a better description, again, to identify barriers to adoption and help find ways to reduce those barriers. Next slide, please. So what are the key drivers for adoption? Well, obviously there's quite a few. I won't read the slide to you, but the biggest one, I think, is anybody probably recognize, certainly in the United States, it's going to be electrification, although it's probably true around the world as well. There's going, you know, depending on your views on decarbonization, how quickly it'll take place, how much more renewable energy is going to be entering the grid. Now we have the new small modular reactors as well. You know, depending on who you believe, again, we're going to need to double, maybe triple the size of the grid in the next, again, 10 to 20 to 30 years. And that's probably going to be the biggest driver in the U.S., although there are obviously very related to that other drivers. Internationally, I think Dave talked a little about this earlier. Several, you know, the international development banks, they have decarbonization goals. So that's a driver specifically outside of the U.S. Obviously, there are decarbonization goals within the U.S. and utilities that are aggressively pursuing those. That'll be a driver as well. We'll talk in a second about conductor efficiency standards, and also some progress and an opportunity recently result of some legislation in Montana. Next slide, please. So here, talking about what would be a big driver in the U.S. Well, obviously a potential big driver to the adoption of high efficiency conductors would be an efficiency standard. In the electrical ecosphere, everything from the point where electricity is generated till it's used, there is generally an efficiency standard of some type for almost everything, from power plants, maybe not specific, but it's a very competitive issue at the power plants, all the way to light bulbs and motors and in between. The one area, even transformers have an efficiency standard out. The one part of the electrical infrastructure does not have an efficiency standard at this point in the United States, are the transmission lines themselves. And recognizing that Congress directed the DOE to evaluate the benefits of an efficiency standard. That was enacted as part of the appropriations bill last year. They had 180 days, DOE had 180 days. They have not met that goal yet. I think part of it is they're spending a lot of time looking not only at the direct first order benefits of an efficiency standard, but also if you adopt an efficiency standard, you'll bring advanced conductors and other technologies onto the grid. And there's a lot of secondary benefits, as Dave described earlier, considerably more capacity and also significantly lower line losses. Next slide, please. So what is the status? I guess I kind of jumped ahead here myself. So they didn't meet their 180-day goal. The OE has been charged, is also charged with this study, and we have seen some questions and engagement. It seems like it looks as though that Oak Ridge is taking the lead from the DOE lab world. And there's, speaking of fans of advanced conductors, that's Senator King actually holding up a sample at a recent hearing talking about the efficiency standard study and other innovative advanced transmission technologies. But as last line mentioned, we have a number of people ready to go on promoting, maybe even on a legislative basis, efficiency standards once the study comes back. So here's one recent big win in the United States, Montana House Bill 729, of kind of unique, basically as a way to encourage the adoption of high efficiency conductors. The state of Montana recently passed a law that allows in Montana, the Public Utility Commission is actually called the Public Services Commission. It gives the Public Service Commission the authority to provide a rate of return adder when using high efficiency conductors. The thinking and the fact being that the incremental rate of return adder that the utilities would get will be more than offset by the efficiency savings. So this is actually the law. And if we go to the next slide. How did it get accomplished? So Montana's, for one thing, Montana's unique. My colleague who you saw on the first slide, Dave Townley, met Commissioner Pinocci, who's a commissioner on the Public Service Commission in Montana, at actually a NARUC meeting, I think 3 years ago, and the commissioner was very enamored with the advantages and opportunities presented by advanced conductors. Montana, as I mentioned, is a little bit unique. There's only about 10 states that elect their public service or public utility commissioners or public service commissioners, and more, even of that 10 or 11 states that do that, only 3 or 4 actually elect them on a geographic basis. Most are done statewide. So the Commissioner Pinocci, is one of 5 commissioners in Montana, and he actually represents a very specific geographic area. And that area is what's called coal strip. And so there's a lot of power generation there. There's a lot of transmission there. So he was particularly interested in ways to improve efficiency, improve capacity in not only statewide in Montana, but actually in his district. What's really interesting about this, and it was kind of a unique situation as well, Commissioner Pinocci was previously, his background, he was previously the state director for Senator Burns, and actually for several other congressmen in Montana. So he's actually a experienced politician, and in fact was a legislator in Montana before he ran for and was elected as a public services commissioner. And I guess part of that is he knew a lot of the legislators, and this law passed both the Montana House and the Montana Senate unanimously, and was signed by the governor in May, and is I think everybody, we knew that there was a good chance, but I think everyone was surprised by how well supported this was in the state. Next slide, please. So the first project that will take advantage of this rate of return adder, which the Public Service Commission, Montana Public Service Commission, needs to establish, is underway. And there's the Public Service Commission has begun the process of establishing this higher rate of return. We don't know if it's going to be a quarter of a point, a half a point, somewhere in between, but there will be a rate of return adder on this first project. Next slide, please. So what this is, we're not stopping here. There are other innovations coming in the advanced conductor space. We've integrated fiber optics into our product. We've just announced or about to announce our most recent version of that, the most recent update, which will allow enhanced verification before, during, and after installation, and even several years after installation as well. That'll be reaching customers very soon. And then just generally, there's some research being done on more conductive, lower resistant materials for conductors, not just by CTC Global, but our friendly competitors in the field as well, to actually even improve further the efficiency advantages that the advanced conductors have. And I think that's almost the end. Maybe there's one more slide. Nope, there you go. So we're happy to answer questions. Appreciate the time. And here's Larry back, and I think he's going to MC the rest of the program today.
Yeah, thanks, Peter. Thanks, Dave. That was a really great presentation. Dave, I want to specifically express my appreciation for your plug for some of the past WIRES reports that have touched on this issue. And I'll just mention that those are available on the WIRES website for folks if they want to follow up with that. So your presentation did spark a few questions, and they've started to come in already. I encourage others, if they have questions, to put them in using the question function, which is on the right-hand side of your screen. And I'll go through those, and then I have a few of my own I'd like to hit on as well. The first question I got was, and I don't know how extensive this list is or whether you know, but it says, who are all the ACCC stranders around the globe?
I'm going to have to give that to Dave. He'll know them better than I, but there's like 35 or 40 of them, I think. So Dave, rattle them off.
Well, the easiest way to do it is go to the website, and there's a page that's got all of their logos. But I mean, we've been,
is that?
CTCglobal.com. It's on the slide down here. Easy to find.
Okay.
Yeah,
I'm going to suggest they do that rather than you hit off all 35 or 40 of them by name. But it sounds like there's at least a list of people out there who they can consult on that.
Yeah, and again, you can take that offline with me. I'm happy to share contact information with these guys, but we're really fortunate to have been working with many of them for as long as 20 years. General Cable,
that's been our business model, is we provide the core, and because that allows the traditional competitors to actually continue in the business. They wrap the aluminum around it. And just as I think there's Dave, about half a dozen, 4, 5, 6 in the United States alone that we work with.
That's correct. We also have 11 hardware manufacturing partners. We greatly encourage the use of our collet assembly design as an internal way to grip the core inside dead ends and splices. It puts very little stress on the core, won't crush it, won't damage it, and we've had extremely good luck with that. There are at least 1 million of them out there in service with no failure. So it's a good technology. Happy to take those things offline with anybody that has more questions.
Great. Another question I got here, and I'm gonna have to rely on your technical expertise on this, I'm sure too, but it says, shouldn't we be comparing composite core conductors with ACSS trap wire conductors? It says aluminum content would be the same.
Not necessarily. And the thing that's different is that the ACSS trap wire of a given diameter is also going to have added 25 or 30% more aluminum. You're going to have a weight penalty. And the weight penalty also contributes to sag. So while trapezoidal wires have been around for a long time, and you can order them with higher strength cores. So you like Southwire is a product that they call it's a trademark HS285. It's 285 KSI, which is better than the 200 KSI of conventional steel wires. And then if you switch over to composite core, they can go from anywhere from 300 to 400 KSI. So you have a lot of strength, but you also have a lot less sag. So yes, you can put more aluminum, or you can order a bigger size wire, but you have to be able to contend with that added weight, and that the sag characteristics is very similar to that of ACSR conductor.
Great. And then this question, I think, is teed off of the Montana legislation you were talking about, Peter, but it says, would there be a problem with ACCC in Montana with ice load?
Well, Dave probably can answer that better than we do. Have specific combinations for the northern climate specifically for that. So Dave, I'll let you take that.
Yeah, and even the ice load maps have been changing over the years. Even in Texas, they consider 1 inch of radial ice. We've done 2 things to address that. The composite core is highly flexible. Even though it's really strong and really light, it will stretch if you put heavy weight on it. The good thing is, unlike metal, it will not plastically deform or yield. So after the load is removed, it will return to its original length. Now, as it relates to a conductor, you're going to some of the aluminum strands are going to relax. That's going to lower your thermal knee point. But we do have a higher modulus, higher strength version we call ULS core. And we've also done what 3M and other companies have done, which is rather than use fully annealed aluminum, when we have an extreme ice load condition, or a really long span, we'll use an aluminum zirconium alloy that adds overall strength. It increases the modulus, so it's less stretchy, and it can very well handle extreme winds, extreme ices. And we've got a lot of those installations around the world when that is a concern.
So I've got another question here from someone else, but it might implicate what you were just talking about as well, Dave. It says, do we have some comparison how ACCC is better in performance under moist conditions than ACSR?
Absolutely. So when I met with Southern California Edison back in 2002, and I asked them, what are the concerns that you guys have about transmission lines and longevity? And one of the was, besides vibration, was corrosion. And I've had many colleagues mention me that in some parts of the world, they refer to ACSR as AC-NOR because the steel core can corrode very quickly. You also get a galvanic response because they're dissimilar materials. So when in the presence of moisture, that can further accelerate the degradation. The carbon fiber with the glass has virtually zero impact to corrosion. And you cannot put carbon fiber and aluminum in direct substantial contact in the presence of an electrolyte like rainwater, moisture, or chemicals. That'll really degrade quickly. But having a glass layer around the carbon core gives us great resistance to corrosion and also cyclic load fatigue. We've got a lot of reports. I'm happy to load you up with test reports.
I'm showing a sample there. That's the gold wrapped around the black carbon core. That's the fiberglass that Dave is describing.
Thanks. And then you just mentioned about reports on the performance issues around it with moist conditions. I've got another one similarly about a lot of interest in how the effects of ice load are on these lines. And they were asking, are there any studies comparing or addressing advanced conductors performance relative to other traditional conductors? It sounds like there may be some reports out there, and I don't know whether you can point them to where they can find them, or if it'd be better for them to follow up with you offline. You tell me, Dave.
Yeah, take it offline with me. My email, dbryant@CTC Global, is right there. We've done a lot of outdoor testing over the years. I remember at Deadwater Fell in the UK, they installed a bunch of different conventional conductors and high temperature, low sag, and ACCC conductors, and they measured these things throughout seasonal conditions. So there's a lot of data that's out there on that performance. We also have a software program we call it CCP. That's you can access it on the website, and just if you can, anybody can use it. There's I think 300 or 400 different conductor types and sizes in there, but you can also it's similar to PLS-CAD. It has some other functions that allow you to model how the conductor reacts under ice and wind load conditions.
So that's it. They can contact you at dbryant@ctcglobal.com. You're prompting a lot of questions. I'm trying to follow up on some of these. One is, have you seen any ACCC future proofing considerations from domestic utilities considering the amount of projected load coming online over the next about 5 years?
So future proofing is almost something like resilience. It's a fairly new buzzword. And so future proofing is essentially defined as, you may not need this capacity today, and you may not want to run at 200 degrees C because that you're going to have higher line loss. Now, if we were running at 200 degrees C, the other conventional technologies would be, closer to 300 degrees C. There's a big difference in efficiency at higher temperatures, but having that added capacity really helps ensure that your investment in a transmission line, whether it's a reconductor project or even a rebuild project or a new line, having that added capacity is really good insurance, and you can consider that to be future proofing.
I'll add a little bit to that. We've actually had some discussions where, particularly in Bangladesh, I wouldn't say we're quite at the point where we're spec'd in, but we have a very dominant market position there. And in talking with our customers there, we asked them, why are you so enamored? Why, we were happy. We're not trying to disagree with you, but we're very happy that you really love our product. And they said, their response was, well, we love our transmission planners, but we know that they're generally going to be wrong, and they're going to generally be wrong on the low side. That market is growing so fast, and I described it earlier. We have a war, like the old P-51 fighter planes. We have that war emergency power button that you can hit. You can actually, the conductor actually can tolerate well beyond spec conditions for meaningful periods of times, and depending on the load characteristic of the line, you may be able to get away with a few more years out of a line before you need to upgrade it because of that capability.
Great. Well, I have a question I wanted to follow up too, and one is, what's your experience been with engaging with other, associations or groups like NGOs or things like that on these types of technologies? Have you gotten any reaction or interest from them about how these would all play out?
Well, we are obviously engaging. We're a member of a number of the different organizations. We're a member of WIRES. We're a member of NASIO, NARUC, Advanced Energy United, quite a few entities. And because of that, we end up in contact with a number of entities that you wouldn't think would necessarily be as interested in transmission as they are. And to give you an example, so the quick answer to your question, Larry, is yes. A specific example is was a recently released report by the Audubon Society of all places, and it's called Birds in Transmission. And I found out about it and learned a lot about it because I was on what we call a door knocker on a trip to DC to see congressmen and senators and talk about the transmission issues. And one of the people in my group was one of the co-authors of the report for the Audubon Society. And I guess we should have known this. I did not realize how important to the Audubon Society reducing transmission towers is. I thought that was, most of the issues around bird kills on transmission was birds contacting the lines. But what I learned is that's actually not the issue at the transmission voltages, because the lines are far enough apart. The bird kill is primarily the birds contacting, hitting the towers directly or around the hardware around the towers. So the report's available from the Audubon Society. I'll make sure, Larry, you have a copy of that, so you can provide it to the guests here. But the fact that using advanced conductors are specifically mentioned in the report, and they like the fact that it's fewer towers.
Well, great, thanks. Yeah, provide that to us, and we'll send it around to the registrants, and we can also post it on our website as well for people who are interested in getting information on that. We're getting close to the top of the hour. One other thing I wanted to ask you about quickly, and this is probably not a super quick question, but are there any sources that people should be aware of for funding related to some of the recent federal legislation that's been put into place involving either the IIJA or the IRA that they might want to look at, where they could get a little bit of sense of where they might find some additional aid for these projects?
Yeah, absolutely. So obviously, the two big ones are as you mentioned, are IIJA and the IRA. We're all waiting with bated breath for the first IIJA awards to be announced. We do know that because of the emphasis that the Secretary of Energy has on advanced reconductoring, that the next round of IIJA, or this is all part of it's part of the GRIP program that came out of the IIJA. GRIP program comes out of the Grid Deployment Office. We would expect to see some additional incentives, encouragement, and maybe even set-asides in the next round, which will be, we understand the next solicitation will go out this fall. But yeah, just to keep in mind for those who are interested, the IIJA money and the IRA money are not only funds available through the Department of Energy. Some of that funding, particularly for the co-ops, actually comes through the Department of Agriculture. So keep your eyes out for those opportunities. And the one challenge anybody who's seeking that, interest in that funding, is keep in mind there is a major Justice 40 initiative part of it. It adds quite a bit of overhead to the process. So best to get engaged in that in those interactions as early as you can.
Well, great. Well, thanks for flagging that. We have some co-op members and wires who might be interested in some of that. I got one last question I'm going to try and sneak in before we wrap it up here. It says, they're wondering how long of a span can a CCC conductor be designed for? And says, I'm particularly interested in talking about 2 miles of a span.
We haven't done that yet, but we're all ears. We've done a mile span. Is the longest. It was about two feet short of 1 mile. That was in Africa over a river crossing.
And I might add to that, as that's actually probably, Dave, tell me if I'm saying this wrong, but one of our biggest entries to a customer is they have a challenging application they cannot do any other way. Those are often river crossings, as Dave mentioned. And if you ever come out and visit us, and we hope that people will out in Irvine, California, you will see that our conference rooms are mostly named after river crossings. So there you go.
All right. Well, good. Maybe this person will follow up with you on that then. Well, listen, we're coming to a close here, and Peter and Dave, I really want to thank you for a really thorough, interesting, and informative presentation, and appreciate the time you put into doing this. For folks who are tuning in on this, I want to put in a plug for our next upcoming webinar, which is going to be hosted by Line Vision. That's targeted for November 8th from 2 to 3 p.m. And we're looking forward to putting that one on as part of our series that's going to extend into next year on these different innovative technologies. So Peter, Dave, thank you very much. Thank you, CTC Global, for helping put this presentation together. And we look forward to seeing everybody at our next program on November 8th. So thank you very much.
Thank you to Wires. Thank you, Larry and Drew, for the opportunity and the support.
All right. Thank you. Bye now.
Bye-bye.
Thank you, everyone.